So you might remember early on in the probability unit, I talked about how important it is to be able to count your sample space. Generating a sample space is useful, so that's why we do Venn diagrams and Carnot maps and weighted trees and so on. But ultimately, almost always what we're really interested in is the counting of that sample space, because, say, for example, theoretical probability is like the total number of, the number of outcomes that match what we're looking for over the total number of outcomes. So knowing what they are is more important than the very, very specific outcomes, I suppose. And that's really important to keep track of. So we end up generating or figuring out more complex counting methods that will help us come up with those numbers rather than having to list them out. And why would we do that? Well, it doesn't take very long before trees and Venn diagrams and tables and so on get far too unwieldy for bigger numbers. Like even something like a deck of cards, which is 52 cards. If you're trying to work out the different number of combinations of 5-card hands from a deck of 52, that's quite a large number. And so having a way of being able to work that out is pretty important. So that's what we're doing in this next few videos. We're going to have a look at counting methods. The very first thing we're going to do is have a look at some basic principles of counting methods before we go on to specific formulas. And that's why we're starting off with the textbook here. It's not worth writing stuff out so much as just being aware of these principles, the addition and multiplication principles. So let's get stuck into it. So the addition rule basically says that if you've got different choices in front of you and you're looking at either or in terms of being a valid choice, then really all you're going to do is add up those choices together to work out how many choices you've got in total. So here's the examples. Sandy can't decide whether to wear a wind cheater or a jacket. She has 4 wind cheaters, 2 jackets. How many choices does she have? Well, she's got 4 wind cheaters. She's got 2 jackets. So she can choose from 6 items of clothing there. Okay, so that's it. 4 plus 2. Jeans or a skirt. She has 3 pairs of jeans and 4 skirts. So how many choices has she got? She's got 3 plus 4. She's got 7 choices from jeans and skirts. Okay, so 6 choices for a top and 7 choices for a bottom. Okay, so you just add them up. This is an important bit. This rule is the addition rule. Just add up the choices. The use of the word or in the question implies that you're going to be adding them up. So you've got either or, add them up. Example 3, Alan is having trouble deciding which book to borrow. He has a choice of 3 mystery novels, 3 biographies, or 2 science fiction books. How many choices of books does he have? Well, again, they're just choices, either. So it would be 3 mystery novels, 3 biographies, 2 science fiction books. That's 3 plus 3 plus 2, 8 choices. And let's have a look at the multiplication rule. So James, when travelling home from school, James can take a bus or walk to the main road, and then from the main road, catch a train, tram, or another bus to the destination. So how many ways does James have for travelling to school? We can see a tree diagram here, which will give us bus, tram, bus, bus, walk, tram, walk, bus. So there's 1, 2, 3, 4, 5, 6 different possibilities, just adding up these possibilities, right? So there are 6 choices or 6 ways that he can get home. But note that, for every branch off the tree, we just got the same number of choices along each branch for the second part of the journey. So instead of just counting up the 6, we could just say there are 2 choices to start with, and then there are 3 choices off the first choice, 3 choices off the second choice. So there are 2 lots of 3, which is 6. Another way of thinking about it is not drawing the tree diagram at all, but simply saying, I can see that there are 2 choices to start with, and from each of the 2 choices, there's another 3. So there's 2 multiplied by 3, 6 choices. So you can sort of do that without too much of a fuss. So that's the addition rule and the multiplication rule. Here's Sandy's situation again. 6 choices of tops, 7 choices of bottoms. How many choices does she have for a complete outfit? Rather than doing a tree diagram, which would be quite unwieldy, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 7, 7, 7, like that, we could simply say there are 6 lots of choices for the top, 7 lots of choices for the bottom, multiply them together, and you get 42. And that's basically all there is to it. Okay, page 370 has a summary if you want to have a read of that. But other than that, you can move on to exercise 10A and consult your work schedule just for a couple of questions from 10A, just to make sure that you're okay with this before moving on to the more complex stuff. And that'll do for today's video.